Welcome to IPM Leap. This video is about a very interesting maths puzzle that you can see on your screen. Can you calculate the number of squares and rectangles in this 5x5 grid? Now, before I explain how to do this, I strongly recommend that you try this puzzle on your own, as this is a very important question asked in many aptitude exams. Okay. So let's try and estimate the number of squares first. Can you see there are squares of different sizes in this square grid? In this grid, the very obvious squares that you can locate are the 1 unit squares. But that's not it. There are other squares as well. Like you can see this 2 unit square, this 3 unit square, the 4 unit square, and of course, the biggest one of them all is the boundary of this grid, the 5 unit square. So let's count the number of squares. First, we start with the 1 unit squares. Some of you must have quickly estimated 25. But let me show you how. Because this counting method is going to help us estimate the number of squares of other sizes as well. So squares of 1 unit are 5 along this row and 5 along this column. How many of them? 5 into 5. That makes 25. Let's move on to size 2 squares. So along the row, how many of them are there? 1, 2, 3 and 4. 2 unit squares are 4 along the row and 4 along this column. So that makes 4 into 4. That is 16 squares. Similarly, while calculating the number of 3 unit squares, let's count them along this row. They are 1, 2 and 3 along this row and 3 along the column. How many of them? 3 into 3, that makes 9. Now the 4 unit squares. Along the row 1 and 2 and along the column also 2. So 2 into 2, that makes 4. And the biggest one, the 5 unit square is obviously 1. So we can write this as 1 cross 1, which we know is 1. So let's add these numbers. We get 25 plus 16 plus 9 plus 4 plus 1. That is 55. The total number of squares in this grid is 55. Next, let's count the total number of rectangles. And this problem is a little trickier than the previous one, where we had to count the number of squares. Why so? Because every square is also a rectangle. So our answer should be a minimum of 55, which was the number of squares, right? Can you take a wild guess on the figure for the number of rectangles? A 100? 150? Well, no, the figure is well beyond 200 because there are rectangles of so many sizes in this grid. For instance, can you locate this rectangle of 1 cross 3 units or this rectangle of 3 cross 5 units? Or even this one of 4 cross 3 units, or let's say this one of 2 cross 4 units, or this one of 5 cross 1 units. There are more than one of each size I mentioned, and I have not even mentioned all sizes, right? So if we start counting the rectangles of each size, it will be very complicated and we might not arrive at the correct answer because we might skip some of them or else recount some of them. So what do we do? Let me explain how to solve this problem. So as I said earlier, if we start counting the number of rectangles of different sizes, it will be a nightmare. What we will instead do is find out something that is common to all rectangles. What is that one property which is common to all rectangles in this grid? So let me give you a quick tip here. Think of a rectangle in this way. A rectangle is a figure sandwiched between 2 horizontal lines and 2 vertical lines, isn't it? Let's say, for example, I select these 2 horizontal lines and these 2 vertical lines. Do I get a rectangle sandwiched in between them? Yes, I do. Let's take another example. Let's suppose I take these 2 horizontal lines and these 2 vertical lines. Do I get another rectangle sandwiched in between them? Yes, I do. Right, so that's the clue. First count the number of horizontal lines. How many of them? 1, 2, 3 4, 5 and 6. 6 of them. Similarly, how many vertical lines? 6 of them. Now, a rectangle is a figure sandwiched between two horizontal lines and two vertical lines. So what we need to do is pick two horizontal lines out of 6 and two vertical lines out of 6. In how many ways can we do that? Two unique lines out of 6 can be picked in 6C2 ways, where C stands for combinations. And similarly, two vertical lines out of 6 can be picked in 6C2 ways. So by fundamental rule of counting, together we can pick two horizontal lines and two vertical lines in 6C2 into 6C2 number of ways, and 6C2 has a value of 15. So the total number of rectangles in this grid is 15 into 15. That makes 225. And this figure includes the number of squares as well. Now that you know the counting technique, I am confident that you will be able to find out the number of squares and rectangles in any other grid of another size, say a 6x6 grid. So try counting the squares and rectangles in a 6x6 grid and type in your answer in the comments box below on this page. So hope you enjoyed this video. Don't forget to press the like button if you did, and also press the bell icon next to subscribe to get notifications about other such useful content on our channel. PDF of this lesson is available for free on our website www.ipmleap.com. Happy learning! Hi and welcome to IPM Leap. Today's lesson is on a very important maths trick for fast calculations which can help you a lot in exams. We are going to learn how to multiply two numbers close to 100. And the basis for this trick is our ancient Vedic mathematics, something we all are proud of.